Hello, my name is Sam Christopher for Period 6 Chemistry Honors, and here's my Lewis structure video. So, our first compound is disilicon, difluoride, dihydride. So, if we draw the Lewis dot structures for each of these elements, we'll see that silicon, like carbon, has 4 valence electrons, and it's special because it moves one of the electrons out of the s orbital and into the p orbital so that it has 4 unpaired electrons. Fluorine has 7 valence electrons, and hydrogen has 1 valence electron. So, if we do some math, we can find the total amount of valence electrons that we'll be dealing with here. From silicon, we have 2 silicons, each with 4, so we get 8 valence electrons. Each fluorine has 7, and there's 2 of them, so that gives us 14 valence electrons. Each hydrogen has 1, and there's 2 of them, so that gives us 2 valence electrons. Our grand total is 24 valence electrons. Now to find the total number of pairs, we divide that by 2, which gives us 12 pairs. And we subtract the total number of unshared pairs. So we can count 1, 2, 3 for each fluorine, and there's 2 fluorines. It's going to be minus 6 unshared, which gives us a total number of 6 bonds. So now I'm going to go ahead and start doing like a bare sketch of what it's going to look like. So silicon, which has the most unshared openings, silicon, which has the most openings for bonds, 4, will go in the center, and there's 2 of them. So we'll put 1 silicon here, 1 silicon here. Each silicon has 1, 2, 3, 4 valence electrons. So I'll draw that on the other side real quick. 3, 4, and then we have to draw the bonds now. So let's say we can put a fluorine on each side of here. So it has 1, 2, 3, 4, 5, 6, and its 7th electron can complete that pair of electrons. Same with the other side, 1, 2, 3, 4, 5, 6, 7. Now on the bottom we can do a similar thing with hydrogen. Each hydrogen shares its only electron to complete silicon's pair and satisfy its own rule of duet. Now here's the problem. Silicon still has 2, each silicon still has 1 unpaired electron. So what it'll eventually do is take each of these electrons, move it here, and create a double bond. So on our finished Lewis dot structure, this is going to look like silicon double bonded with itself, single bonded to 2 fluorines, and then the bottom silicon is bonded with 2 hydrogens. And that is the finished Lewis dot structure for disilicon difluoride dihydride. Our next molecule is going to be a polyatomic ion known as permanganate, represented by the chemical formula MnO4, otherwise known as 1 manganese atom and 4 oxygen. So if we draw the Lewis dot structures for each of these, manganese, as it turns out, actually has 7 valence electrons because it's a special transition metal. So that's what manganese looks like. And then oxygen, as we know, has 6 valence electrons. 1, 2, 3, 4, 5, 6. And then we need to do some math to find out the total number of electrons. So we have 7 electrons from manganese, and then we have 24 from oxygen. And then, since this is a polyatomic ion, it has a charge of -1. This extra electron is going to add 1 electron, so we are going to eventually get 32 total valence electrons. To find the number of pairs, we can divide that by 2, 16 pairs. And then we need to subtract the number of unshared pairs. So we have 1, 2, 3 for manganese. And then we have 2 for each oxygen. There's 4 oxygens, so that would get us 8. But we cannot forget to consider the extra electron, which will eventually come in and pair up with an oxygen atom. So that gives it one more unshared pair in one of the oxygen atoms. So our total number of unshared pairs will actually be 12 instead of 11. And our total number of bonds will be 4. So let's begin by drawing some sketches of how it'll look like. So if the manganese atom in the center, 7 valence electrons, and then we're going to have an oxygen on each of its sides. Alright, so the manganese already has fully paired electrons right here, so it doesn't need to worry, oxygen doesn't need to worry about giving it extra electrons. So oxygen instead can just use its 6 electrons to fulfill its own rule of octet for these 3. However, on this one, oxygen does need to share so that it can finish manganese's rule of octet. So it's going to give one of its 6 electrons here. 1, 2, 3, 4, 5, 6. Now, as you can see, oxygen does not have a full outer valence electron shell. So this is what gives it its charge of -1. It'll get an atmospheric electron to fill in its extra missing space right there. So now we have rule of octet fulfilled for manganese in each of the 4 oxygens. So to write this in our completed form, it'll look like manganese is single bonded because in each of these bonds there are only 2 electrons being shared with oxygens, each oxygen having a full outer shell, but one of the oxygen's outer shell has an atmospheric electron in it, represented by the X, and then we put that in brackets. Because of the atmospheric electron, it has a charge of -1. Right? I've been Sam Christopher, and thank you for watching my video on Lewis dot structures.